So hello everybody. At this time I want to tell you how to create a graphene quantum dots by using VESTA. Before we create the graphene quantum dot, what we have to know is the space group of the graphene quantum dot of the graphene. In the graphene, we know that there is some structure that available in materials projects. For example, I will take this idea and we just have to download the zip file. Okay. And after we download the zip file, we can open it. Okay, here I already download it, so let's see. And if we open this one, we can have some. Okay, open file. Okay, so if we just drag and drop this file to the file, like, we can see that there is the structure from the materials project, and we just have to export the POSCAR. I used to edit the file by using the Notepad++. There is a lot of software that you can use to edit that one. So if we can see, this is the POSCAR from the FABs. Okay, and if we want to create a single layer of graphene quantum dot, we can just delete the other layer. Here is this layer, and this one is from different layers. So we just have to delete it, and don't forget to reduce the number of carbons. And if we already save it, we can see here we already have a single layer of graphene. Now if we want to create a one ring graphene quantum dots, we have to increase the unit cells. For example, here we increase to the 5 by 5, so we can see there is a layer of graphene. What we have to know from the VABs or VESTA is this: there is some periodicity. So these atoms here is actually the same atom here. Okay, it's the same atoms. The most easy way to create a single rings, we have to choose which one that we want to create. For example, here I choose these atoms for the single ring of graphene quantum dots. So we just have to delete the others, right? So we have to delete the others. For example, here I show you how to delete all of the atoms. So we can see here. Okay. Oops, sorry. Oh, we missed that one. Okay, so we have to delete this one. And here we go. We have a single. Oh, no. Here one. We have a single ring of graphene quantum dots. What we have to do this next one is we have to export again data. For example, here we code it differently. For example, here, and don't forget to change this one into the output coordinates of all displayed atoms, and in the fractional coordinates, of course. Okay. So we can see in our second file there is 12 atoms, carbon atoms. What we have to do next is we just have to change the number of atoms here. Okay, and if we open this file again, we can see that we already have a single ring of graphene. But this is not the graphene quantum dots, as we know that in the graphene quantum dots there is a hydrogens outside. So what we have to do next is changing these atoms. This is 12, 4, 7, 1, 5, and 9. Okay. So we have to move these atoms. Okay, to the most bottom one. For example, is here 1, and then he said that 4 and 5 is the outer ring. So what we have to know, okay, and then this is 6, this is a 7. Sorry, I used to just let the line is blank for the first time. So thus we can know which line that we have to delete. Okay, the next one is 9. Okay, and the last one I think is 12, is I'm not wrong. Okay, this item number 12, right? So here we go. There is 1, 2, 3, 4, 5, 6. Okay, now that we have a 6, the most outer ring from the carbon, and we want to change it into hydrogen. So now we can see it from here. We just have to add another 6 atoms of hydrogens and 6 atoms of carbons. We save that one, and we can see now there is a, oh, I think I missed some of this. Yep. Oh, I think I missed something. Okay, just Control Z. Oh, I think I missed something. This one, number 7. Okay. Okay, we just have to, I think we miss on the, okay, we have to export again. Oh, sorry. Oh, maybe this, okay, there's a 12 atoms here, then have to check again, one by one, 6, or I just want to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? So the number 12 is the last one, the number 9, number 4. Oh, this is number 12, number 4. Okay, okay, and then this one is number 7, number 1. Number 7 here. Okay. Number 1 is here. And number 9. Then the last one is number 6. Oh, I'm sorry. Okay. So there is a 6 atom of carbon and 6 atom of hydrogen. And now we have to just add this one and delete the number. This is just for us. Okay, this is not important, just to help us when we are confused, a little bit confused before. Okay, and here we go. And we have this one. And we have opened again. Okay. So that is the outer ring is hydrogen, but there is no bonding here. That we have to do is only change the distance between this and this. So we know the distance by using these tools, and we have now that, okay, now the distance is too far, so we have to change the distance, right? If you want to change the distance between this and this, so we just have to reduce the number of it sorry, in here. So this is number 7. Okay, if you want to check it, number 7, right? 1, 2, 3, 4, 5, 6, 7. Okay, we just have to decrease the distance. I just show you here for uh, 1 hydrogen atoms, and you can see, oh, this is a little bit. The easiest way to change the number here is by looking here, by using Excel, of course. By using Excel, we can know that the distance from the hydrogen is here, 0.6, 0.6, and then this is 0.54, and this is 0.46. We want to decrease the distance, and we know the distance of this is 0.07, so if we want to decrease it into 0.55, okay, so it's mean that, okay, so okay, second. Oh, I know. So this one and this one is 0, oh yes, this one minus this one 0.07, right? And then this one minus this one is 0.5. So if we divide it, this is what this one, okay? So if you want to know, and then we just have to seek the number here, and then, oh, I'm sorry, I think, okay, so here, okay, this is a simple algebra, I think. Okay, so this one is, and let's see the result. And here we go. We have but maybe too close. You just have to change the distance letter. So I think this is the hardest way to create graphene quantum dots from the POSCAR. If you enjoy the video, don't forget to leave the like button, and thank you very much.